Dear students, this is second part of today's lecture, chapter 1, electrostatics, and we are going to discuss Gauss's law of electrostatic. Before starting Gauss's law, this is very important to know that if a point charge is outside a sphere, then you can see clearly from the diagram that the flux entering the surface is equal to flux leaving the surface. Then total flux will be 0 because flux entering the surface is equal to flux leaving the surface. Actually, this is the basic concept of Gauss's law, because Gauss's law only works for closed surface. If the surface is open, then total flux would be 0. Gauss's law states that the total flux through any closed surface is equal to 1 over epsilon naught times the total charge enclosed by the surface. So there are two very important points in this statement. The important condition of the Gauss's law is closed surface, and the second important condition is the total charge enclosed by that surface. Mathematically, Gauss's law is given by the total flux is equal to Q divided by epsilon naught. Dear students, remember, we often refer to a closed surface used in the Gauss's law as a Gaussian surface. These are imaginary closed surfaces, and there need not be any material object at the position of the surface. Now let us consider a closed surface and a point charge is placed in the middle of the closed surface. As we know earlier that the Gauss's law depends upon the total flux, and flux is equal to the product of electric field and vector area. We know that the surface area of the sphere is 4 pi r square. This would be equation number 2. And we also know that electric field intensity due to a single point charge is equal to Q divided by 4 pi epsilon naught r square. By putting these two equations in equation number 1, we will get the total flux is equal to E, that is Q divided by 4 pi epsilon naught r square, multiply by area, that is 4 pi r square. By cutting 4 pi r square with 4 pi r square, we will get the total flux, which is equal to Q divided by epsilon naught, which is the statement of Gauss's law, that total flux passing through a closed surface is equal to 1 over epsilon naught times total charge enclosed by the surface. Now look at this situation. If we have many charges in an irregular surface area, then flux for Q1 would be Q1 by epsilon naught, flux 2 would be Q2 by epsilon naught, and so on. Flux n would be Qn by epsilon naught. Now total flux would be equal to flux 1 plus flux 2 plus flux n, sum of all the fluxes for all the charges. Then the total flux would be Q1 by epsilon naught plus Q2 by epsilon naught and up to so on Qn by epsilon naught. By taking 1 over epsilon naught common, we will get sum of all the charges. And we know that sum of all the charges is equal to capital Q, a large charge. So again, the statement proves the Gauss's law, which is the total flux passing through a closed surface is equal to 1 over epsilon naught time total charge enclosed by the surface. Dear students, at the end of today's lecture, your assignment is to solve this very important application of Gauss's law. You have to find the electric field intensity due to infinite sheet of charge. Thank you very much.